Welcome to my channel. Today I am going to explain about simplex method in operation research. The given problem is using simplex method solve the following LPP. Maximize z is equals to 3x1 plus 2x2 subject to constraints x1 plus x2 less than or equals to 4, x1 minus x2 less than or equals to 2, where x1 comma x2 greater than or equals to 0. This is the given problem. We have to provide the solution for this problem. Solution. Step 1. The problem is maximization type. Maximization type. The given objective function is maximization type. That is, in the given problem, maximum z is equals to 3x1 plus 2x2. Sometimes this is called the objective function. Sometimes this will be given as the minimize z. If minimize z is given, we have to convert to the maximize z by multiplying on both sides -1. We can get maximize z. In this problem, maximization only given, conversion not necessary. Step 2. All BIs are positive type. BIs means right side elements. These are called the BIs. These are positive only, not negative. If negative are given, suppose in the problem negative are given, we have to convert to the positive by multiplying on both sides -1. We get positive. Always BIs are positive. Step 3. Convert all inequations to the equations by adding necessary slack variables. Here in the problem given, all are less than or equal to type. These two inequations we have to convert to the equations. Something we have to add left side to make equal with the right side. Left side, right side we have to make equal means some quantity we have to add left side. Suppose 5 less than 8. To make equality we have to add left side some value. This is called the slack variable. Whatever we are adding left side to make equal to the right side, that is called the slack. Let S1, S2, S3 are the slack variables. The given equation, the inequations 1.s1 plus 0 dot s2 equals to 4. Equation 1, x1 minus x2, 0 into s1 plus 1 into s2 is equals to 2. These inequations are converted into the equations by adding. These variables are called slack variables. To make left side we have to make equal to the right side, we have to add some quantity. We can get these two equations. Obtained new objective function with new slack variables with 0 cost. Z is equal to 3x1 plus 2x2, 0 into s1 plus 0 into s2. Z is equal to Cj is equals to, this is the cost, x1 quotient 3, x2 quotient 2, s1 quotient 0, s2 quotient is 0. This is called the cost vector. Step 4. Obtain initial basic feasible solution. Search z equals to 0. We have to find out the initial basic feasible solution. Case 1. In the previous class I told about this one, how to find out the basic feasible solution. x1, suppose x1 equals to 0, x2 equals to 0. Non-basic solution we are getting. These are the non-basic solutions. Z equal to 0 plus 0 equals to 0. Substitute it in equations 1, 2. x1 equals to 0, x2 equal to 0. We get s1 equals to 4, s2 equals to 2. In this equation, x1 value 0, x2 value 0. Then s1 is equals to 4 we are getting. x1 0, x2 0. Then we are getting s2 is equals to 2 from just substitute equations in equations x1 value 0, x2 value 0. Then we are getting s1 equals to 4, s2 equals to 2. I written this one here. s1 equal to 4, s2 equal to 2. Put all the results obtained in simplex table. Matrix form. Ax equals to, before writing the simplex table, write the matrix form. Matrix form is Ax equals to b. 1 1 1 0 1 minus 1 0 1 x1 x2 s1 s2. These are the quotients. Only in the given equation. Quotients 1, x1 quotient 1, x2 quotient 1, s1 quotient 1, s2 quotient 0. These are written in the matrix form only, that we are getting. Right side elements are 4 2. Now we have to write the simplex table. CB basic variables XB X1 X2 S1 S2. Cost vector. Basic solution. This is the basic solution. This is the cost vector. These values are, we can get 3. This value is the 3 to this x1 quotient 3 in the objective function, x1 quotient 2, remaining 0 0 in the objective function. Just S1 basic variables are S1 S2. It's a cost 0, it's a cost 0 only. Just you write the XB value 4 2. Just writing the values. Just these values are writing in the simplex table. 1 0 1 1 0 0 1 minus 1 0 1. Delta J is equals to Zj minus Cj. Zj is equal to Cb Xj. Just we have to multiply 0 into 4 0, 0 into 2 0 only. Again we have to do here 0 into 1 0 into 1 plus 0 into 1 minus 3. Here we are getting Cj value minus 3 is there, minus 3. This value we are getting minus 3. In the similar manner we have to do 0 into 1 0 plus 0 into minus 1 0. Here Cj value minus 2, remaining 0 into 1 0 0 into 0 0 0 there. In this one we have to find out most negative value minus 3 minus 2. In this most negative value is the minus 3. Select this column as the key column. And next theta value we have to find out. Always theta greater than equal to 0. Xb by xk greater than 0. Just we have to divide 4. Ratio we have to find out. This ratio 4 by 1 is equals to 4, 2 by 1 equals to 2. This is the minimum value we are getting. This 4 to minimum value is the 2. We have to select this row as the key row. Always key element, this is called the key element. Always key element we have to take unity. Already unity means its value always 1 we have to take. Already here this value is the 1, not necessary to convert 1. Already here this value is 1 only. Next table CB basic variable XB X1 X2 S1 S2. We get this is the incoming vector. Incoming vector is the X1 and outgoing vector is the S2. In place of, in the next table we write S2 plus X1. X1 cost is the 3, S1 0, that is X, that is here X1 cost 3 only. This remaining as it is there, 2 1 minus 1 0 1. Here new Q row, this one we have to find out this row value. We have to find out 4 1 4 1 1 1 0 minus 1 2 1 minus 1 0 1. If you make these calculations, we get 2 0 2 1 minus 1. Its cost will be cost vector 3 2 0 0. Again we have to find out the net evaluations. Net evaluations we can get 0 into 0 plus 3 into 1, 3 minus 3 0 we are getting. This value we are getting net evaluations. We have to find out 0 into 2, 3 into minus 2. Here also minus 2 we are getting. This is minus 5. 0, 0 into 1 0, 0 into 0, 0 we are getting. 0 into minus 1 0, 3 into 1 3 we can get. Most negative value is this one. And next 2 by 2 1 we are getting. This is the negative. Key row, this one. Next we have to make, this is called the key element. Always key element will be unity, 1 will be there. Complete row we have to divide by 2. Then we can get this value is the 1. CB basic variable XB, X1, X2, S1, S2. These values are 3 2 0 0. Now we have to find out the x2 value. Here what will be happening, this one x2 is the incoming vector, s1 is the outgoing vector. X2 here its cost will be 2, x2 cost 2, x1 cost 3 we are writing. And next we are getting complete, this complete row is divided by 2, 2 by 2 1 0, 2 by 2 1, 1 by 2 minus 1 by 2. We are getting these values 1 0 1, 1 by 2 minus 1 by 2. Now we have to find out the this value we have to find out, that is 2 1 minus 1 0 1 plus 1 opposite to this row. Key element opposite value we have to take, that is the minus 1 will be there. If we take here plus 1 becomes, and as it is we have to write this values 1 0 1, 1 by 2 minus 1 by 2. We can get the values. If we complete this calculation, we can get the values 3 1 0 1 by 2 1 by 2. Just to find out the net evaluations again, 2 into 0 plus 3 into 0, 3 into 1 minus 3. We have to get 0 here. Here also we can get 0. Here we can get 5 by 2. Here we can get 1 by 2. Now we stop the process. Since all delta j's are greater than equals to 0, the required solution is x2 equals to, just we are getting x2 is equals to 1 x1 is equals to 3. Maximize z equals to 3x1 plus 2x2 is equals to 3 plus 1. This value we are getting. Maximize z equals to. Thank you.